Hello guys, this is the first video in this tutorial series on heat transfer analysis for PCB in Abaqus. In this first part, we'll explain some basics on the theory and on the parameters that we're going to include in this analysis. And it will be a steady state analysis, and we will include both the conduction and convection modes. So what is of high importance is defining the thermal conductivity K. This is the governing equation for the heat transfer problem, and the K is typically given in these units, watt per meter times Kelvin, but since we use the millimeters for our part, we are on this column. This is the very famous table for Abaqus users, the table for the unit consistency, and we have to make the conversion to the millimeters, and this is the values for some materials. Okay, so next we have to define the convection coefficient, heat transfer coefficient H with index 3. This is the coefficient that we will assign on the film condition that will simulate the convection between the air and the PCB of the external surfaces. We are not going to solve the CFD problem. So here are various conditions for still air or natural convection or forced convection. And this is the values for each condition. This is the column of the conversion to the Abaqus millimeter SI. And personally, I choose values between 5 and 10, and I calibrate my model and validate it with the tests. So guys, we are going to perform a detailed analysis in which the PCB will be divided into multiple sections representing the various copper and the electric layers, and we will also include, as you may see, one component on the top surface on which we are going to apply the load for this analysis. So stay tuned. Thank you for watching.